Hi, my name is Johnny Verganio Cayamso. Uh, I'm going to present my final project for Introduction to Data Analytics Modeling. So my project is all about package singulation and KNN clustering algorithm. So for the table of contents, I'm going to course through the different section which is the introduction, problem description, the objective of this project, the theoretical framework, research methodology, results, and the conclusion. So what is package singulation? Package singulation is a process in semiconductor industry that converts the molded strip or array of devices into its final single form. So this process may use different cutting method that will depend on the condition of the material to be processed or per customer requirement. This cutting method could be punch die, laser cutting, or by using a dicing wheel. So the main objective is to cut these sets of units into its final form or final dimension in both uh, X and Y direction, or let's say the length and the width of the devices, according to its package outline drawing. For the problem description, so with the current advancement on technology, devices are getting smaller and equipped with tons of features, which is becoming a challenge to simulation process. So this new technology are introduced with sophisticated designs or compacted with different layers of materials such as coppers, which in the end causes different variations on the material like deformations, expansion, or shrinkage. So these conditions greatly affects the precision and accuracy of the process, which results to cutting related issues like high packages, low package dimension, and offset cutting. Excuse. For the objective of the project is the main objective is to develop a model that will be used as a tool to identify correctly the device by analyzing its actual dimension using the package dimension data set of 12,779 of a few identified devices that were processed in singulation. So for the theoretical framework, this project will use the dimension datasets that we have instructed from the inspection report of the lots that were processed in singulation. So we're going to use the dimension on X of the package and dimension on Y, which is equivalent to the length and the width of the device. So these material characteristics will be used to identify the device to which it belongs to. So KNN clustering algorithm will be used to generate our model since our dataset refers to the characteristic of the identified device that are not supervised and will be set into different groups or clusters. So for the research methodology, we have the data processing wherein we're going to load the package dimension datasets, overview of the datasets wherein we're going to plot the data information and identify the clusters by device. And then we have the elbow method wherein we're going to calculate the clusters within the cluster sum of squares for different values of k and plot the line graph to determine the optimum quantity of k or quantity of clusters. Next is generate the model using the KNN clustering algorithm with applying the optimum quantity of clusters. And then we have this section in the code wherein we call it mapping the clusters, which is used to identify the actual device name based on the cluster of the classified data. And then the last part is the program testing, wherein we're going to enter the dimension and validate if it will be classified correctly by the model. So as a result, we have the data processing. So in this area, we have loaded 12,779 in the program, as you can see here. The table below shows the distribution of the data per device. So we have 6 devices with different quantity of data. So for the overview of the data, this is the scatter plot of the package dimension dataset. So we have here the scatter plot shows the distribution of the data per device, and it shows we have 6 uh, package dimension data, or 6 devices with different dimensions. On this page, it's the graph of within clusters of sums of squares, and in this graph it shows the elbow or the kink where the optimum clustering where the optimum number of clusters are located. So with the aid of these graphs, we can identify the optimum quantity of K to be used for clustering and use it to generate our model. So generating our model, so here is the code that we have used, and then it was able to generate the different clusters of the 12,779. So it was separated in 6 clusters. So for the mapping of the cluster, so the table below is the map cluster. The map clusters of each devices. So for cluster 1, it was mapped as the SKY 59724 device. So as you can see here in the bottom, the second column, which is 58292. The third column is the 59723. The fourth cluster or the column is 53822. The fifth one is the 51001. And the sixth cluster is the 59727. So for program testing, we have tested different sample dimension of each devices. And on the right side is the data reference that I have used in order to identify the correct device, and also the mapping of the clusters. So for the first sample, we have inputted dimension of 2.466 and Y dimension of 1.41, which refers to the device 2.47 by 1.43, which is SKY 51001, and in the mapping clusters, which is also cluster number 3. So as you can see here, the result was tally with the identified devices and also based on the clusters. So for the second samples, we have 1.98 by 2.48. So this falls under 2.0 and 2.5 dimension, which is the 58252. And based on the result, the cluster is 1 and the device is 58292, which is according to the map information of the cluster. The third sample is 2.1 by 1.88, which is under this device 59723. So based on the result, the model was able to identify it correctly. The next sample is also 2.09 by 1.71, which falls under 59724, and based on the result, the model was able to define it correctly or classify it correctly. The next sample is 1.29 by 1.31, which falls under 53822, which is also got correctly by the model. Last is 2.11 by 2.095, which falls under 2.1 by 2.1, which is 59727, which was also predicted correctly by the model. So in conclusion, based on the result of the validation performed, developed model was able to meet the objective of the project. With KNN clustering algorithm applied on the package dimension dataset, it was able to classify correctly the device information of the sample test dataset in the program. In addition, inclusion of another type of device characteristic is also recommended in order to make the algorithm more precise, especially for devices uh, with the same dimension characteristics. So I will go now uh, for the code to demonstrate the functionality. Now I'm going to present the code. Okay. So here I'm going to clear the environment just to be sure. Fine. On this section, I'm going to upload or load the data. So in this section, we're going to graph the scatter plot in order to identify the clusters. So it's taking to yeah. So here's the graph scatter plot of the data sets. So we have 1, 2, 3, 4, 5, 6 data sets. So on this section, I have set a loop that would request the user to input its recommended clusters to be used during the computation of the within cluster sums of square. So here it will ask me, so for quantity of clusters, so I will initially put 10 clusters, enter, and then run the program again. So in this section it will now calculate the total within sums of square to get the different values of k, and then show the line graph and be able to identify the elbow or the kink. So here's the graph of the within sum of squares unscaled data. So as you can see here, we have the 6 as our optimum. So I have another loop wherein it's going to ask the user what is the optimum clusters to be used. So it's here. So I'm going to put now 6 clusters, and then it will ask to confirm if the input information was correct. Yes. Okay. So now it will generate the model using the k-means model, k-means clustering. So here's the generated table. For cluster 1, we have 2,500 data, 2,054 data. Cluster 2, we have 1,500 data, and so on and so forth. So it will now compare the table in order to map the device, the actual name of the device according to the clusters. So as you can see here, cluster number 1 is 59724, cluster number 2 is 58292, cluster number 3 is 59723, and number 4 is 53822, and number 5 is Sky 51001, and number 6 Sky 59727. So now in this part, we are going to test now the model. So for the initial data, which I have shown in the report, which is 2.466 by 1.41, which is Sky 51001, and it was identified correctly. So I can also let's try adjusting or changing these values in order to validate if it will correctly identify. So supposedly on the second sample, the data should be 58 to 92. So I will try to input the 59723 here. I want to 1.98 by 2.48, and I'm going to input the values from the from the third sample, 1.88. Okay, so supposedly the model should be able to identify that these values are 59723. Run. Yeah, so here's the result. The second sample was identified correctly as 59723 data. So that's all, and hope you have a good day. Thank you, sir. Bye.